myself from.
Hello. Yeah, we're live. Uh, Hi, Andrew. So we are live a bit ahead. We will start at 11:30 sharp.
Great. Looking forward to it.
Yeah. Everyone who is live, please share this with your friends so that everyone can join, and this will be helpful for everyone.
Not sure if you can hear that background noise. The neighbors are a bit noisy today, unfortunately.
Yeah. So I think there is still 1 minute, but let's just start. People might join in. So till that time, I'll introduce you. So hi everyone, thank you for being here. Thank you, Andrew, for taking out your time. Today we have with us Andrew Hasheska. He's in Google and he has more than 18 years of experience in software infrastructure and services industries. He's right now the APAC technology practice lead for application modernization at Google, leading the team responsible for delivering on the modern application vision. So, and today he'll be talking about monoliths to microservices. So, thank you for being here, Andrew. Looking forward to your session.
No problems. So I understand I've got an hour of your time today. So this is a topic that I guess is evolving within many organizations that I've spoken with. And I thought it would be useful to do some sharing in our community group. And we're trying to spread this message all across Asia Pacific. And given I look after app modernization here at Google Cloud, one of the things that I'm finding is this topic is really beyond just technology. You can't just implement some software or a cloud-based solution and have modernized your application. There's a lot of transformation that needs to happen around governance and control and people and processes and culture. So we'll talk about some of those things as we go through. But just for a bit of context before we start, when I talk to organizations across Asia Pacific, I typically see that they're in varying stages of modernization in terms of maturity and where they run their workloads, how far along their containerization and CI/CD approaches they've come. But I guess some initial views on percentages that I'm seeing resonate across the market. To start with, a very large proportion of organizations I speak to in APAC are still running workloads on-prem, and almost 90% of these organizations are trying to build new containerized workloads and trying to modernize existing Windows and Linux virtual machines, in some cases mainframe, and moving mainframe workloads to containers and Kubernetes as part of a strategy for the year as well. One other point here is that typically most organizations that we talk to, and I'd say 90+%, are looking at operating a hybrid or multi-cloud deployment. So having potentially more than one cloud, being able to leverage their investments on premises, and being able to have that improved manageability and lower maintenance overhead for doing that. And it's about choice, really. So if we think about app modernization and what it does for businesses and how it helps developers, most people I speak to when we talk about app modernization think about Kubernetes, in its open source context. They might think about Istio as a service mesh, or Knative for serverless, maybe more recently Tecton for build. But when we elevate that a little bit further to businesses, often it comes down to these four things. Having a look at the application architecture, moving from monolithic estates to microservices, abstracting away from physical servers and virtual machines to containers and clouds, elevating and abstracting away from that infrastructure layer, improving software delivery. So there are many ways to do this, but one of the aspects is potentially moving away from waterfall software delivery approaches to agile CI/CD and DevOps. But the last one there is probably one of the bigger considerations from businesses that I've seen last year and this year, which is moving away from proprietary software where possible. Now, that could be a proprietary application running on a proprietary operating system, maybe even a proprietary appliance. And I guess the real push these days for organizations is to move as much away from that proprietary lock-in, make their applications portable, and move to open source where possible. So let's think about this a little bit further. Think about cloud native and I guess what that first generation of cloud native actually meant for many organizations. It was typically all about infrastructure automation. It was about virtualization. Maybe infrastructure as code, maybe applications on pipelines, and some containerization there, and a real focus towards, I guess, the platform. And delivering workloads on these pipelines, maybe with security by configuration. But what we're seeing, I guess, in the second generation of cloud native is a real focus on applications and sustainable scale. So this is where we're thinking about things like virtualized namespaces and Kubernetes resource management for not only Kubernetes objects, but all objects. Event-driven architectures, migration factories to move and modernize workloads seamlessly and very quickly, and I'll talk about that towards the end. And I guess security by design, so shifting left on security in your pipeline, declarative configuration management, GitOps style approaches, and SRE practices not only scaling to the DevOps team, but available to all IT teams. There are a couple of issues that we see with open source technologies. And I was talking to a customer in India a couple of weeks ago, and they mentioned that they had deployed Kubernetes. And they were starting their journey, but one of the main things that sparked off this conversation was the overhead that they spent in managing open source Kubernetes in their environment. They hired over 20 people to just go and manage Kubernetes in their environment, which seems like a big investment in human resources, where really running a modern platform should be easy. It should be simple. You shouldn't be spending more time configuring infrastructure. You should be spending time less time. Now, I guess one of the other things is, for businesses, open source technologies are typically driven by a developer ecosystem. Often that may not have a security first posture, even though there are tools available to do this. Many organizations have found that the governance and control that they may have deployed in data centers is maybe not the same when they're deploying in containers and across clouds. And that portability has lent itself to maybe abstracting away from the security postures that they've known to something that may not be optimal for their organizational standards. So if you think about some aspects that are being considered to resolve some of these challenges, the journey typically starts from the bottom up. So there are a couple of things that correlate to SRE culture, and I mentioned SRE available to all IT teams in a previous slide. But two of the basics for SRE culture is maybe accepting failure as normal, reducing those organizational silos, having a blamelessness culture, one common vision, good knowledge sharing, and as we move up, being able to implement gradual change, work in small batches, include automation and change management in everything that is done to release software to market. And then the last one around measuring everything. So having transparency, across the infrastructure, across the applications, across how the consumers might receive this service. All of this should be set at a business level and correlate to all teams supporting the vision. So if we think about the future of applications, typically we're thinking about infrastructure and I guess the platforms that applications run on should be created with containerized microservices. They should be managed through a declarative system with a single control experience that uses a service mesh to span all application locations. So we've mentioned some of the themes around what application modernization is, but why would we consider this? And then I'll get into some of the details around how we can break away from some of those monolithic architectures. But in order to convince a business to move forward in strangling their monolith and breaking up the monolithic architectures they have in the microservices, they really need to have a compelling reason as to why they're going to spend this effort. So some of the benefits that we see resonating with businesses might include improved speed, agility, maybe improved reliability for applications as they service customers, improved and more dynamically scalable security and compliance, and avoiding that proprietary lock-in and vendor lock-in. So these are some of the things that may help to set the scene as you continue this conversation with your organizational leads. Now, to get started easy, the first thing we really need to think about is what can we do with what we have? Often a big transformational project might have a few hurdles to get started with and to implement. So if we can think about using what we've got and starting where we are and modernizing and optimizing in increments, based on the current state that we've got, then it's often more achievable. So if we think about modernizing in place, it may be on-prem, it may be on a chosen cloud, and starting with automation of policy and security at scale. GitOps model, have your manifest stating all of your security, configuration, compliance options that you would like to apply across all of your clusters. Will hopefully then give you that consistency. And if you then start benchmarking and measuring consistently across all of the environments, then that's a pretty good baseline to start with. Now, in terms of what we're trying to do here, elevating the experience for managing modern apps starts with a simplified management approach, has a set of consistent controls regardless of where that workload runs. They've got a flexible deployment model that can be deployed repeatably and portably anywhere, and maybe extensibility to go and replace proprietary applications and services with centralized billing through open source technologies. Now, some personas that we're engaging with in this space, I often think that everyone is a developer these days. If you're a security admin, you're likely deploying security in a manifest and hopefully scaling it across your environments. If you're a platform operator, you're likely looking at infrastructure as code, you're looking at repeatability and automation, you're looking at that consistency between on-prem and the cloud, and maybe you're being a lot more API focused to ensure that the tasks that you run are more portable. And I guess if you're in the developer space, and I know this is a Google developer group, but I've come across GDGs that have a mixture of all three of these roles. I would say that on the application owner and developer side, service automation and traffic control and DevOps have been key themes for some time. But maybe observability and visibility and application performance monitoring, and being able to fully integrate continuous integration, continuous deployment across the ecosystem of services that we run has not yet reached maturity. So there are some things that we can do in this space. But if we're going to pivot and think about existing apps, I find that newly built applications are typically quite a small percentage of applications that are run in organizations. So if we want to think about where the larger opportunity for change and transformation is, for you all to be heroes within your organizations, it's about looking at the traditional workloads that we have and how we can accelerate and improve those large volumes of applications that have potentially been built and have been running for decades. So for these legacy applications, often rewrite is a challenge. It's not a viable option. For many workloads, I'm talking to a healthcare organization running an ERP system, and that ERP system is written in RPG code, which is rather old these days. It's difficult to find people that can update it. And I guess being able to run it across many different platforms and clouds is a bit of a challenge. I'm also working with a financial organization running one of their key billing systems in COBOL. And I guess COBOL / pack-based are not particularly portable. Many organizations may choose to emulate COBOL on a cloud platform, but I would say that the real goal should be around how can we transform this and I guess leverage the code transformation tools that we have to move to something more modern and dynamic and scalable, where we can choose to maybe run it on top of a modern application fabric. So often, if we think about transformation and digitization, lift and shift is not achieving those goals for organizations. It's basically picking up an application in its very static state, maybe hopefully moving its dependencies with it, but still retaining that tether to the operating system that has a larger surface area for security flaw, performance impact, and issue, and maybe higher volume of maintainability issues that come across those operating systems. So I guess the one thing that we want to consider is migration needs to consider a lot of different factors. So I guess the recommendation, and the better option that we can consider that allows us a faster time to market than a pure rebuild. And if you're in the developer space, I would say that rebuilding a legacy application from scratch can take a lot of time, can be a bit of a challenge if you haven't worked with the source language before, and I guess might have more effort involved than what you'd like included in the project. So I'd say that there are a couple of incremental steps that we could start with before we consider completely extracting the services out of the monolithic architectures. And we'll get to that very soon. I've got pretty much 7-step approach that gives some incremental changes to go and make that happen more seamlessly. But I guess if we consider the options in green, we're looking at improving and moving at the same time. Rather than lift and shift, we're looking to take those virtual machines, move them to containers and Kubernetes, make them portable across on-prem, edge, and the cloud. And we're looking to automate that and moving more down the cloud native stream and outbound to cloud. Now, I would say cloud typically because organizations are running out of real estate. It's a common issue across many countries that I'm working with. And giving scale and performance options and baked in security and having your cloud provider be your SRE can be a better way to work and might require less administrative effort on your side. So The migration path from these traditional platforms to a modern apps platform typically starts with identifying the workloads. And it may sound simple, but I meet with a lot of organizations that don't know where to start with this journey. And if we consider identifying workloads and understanding the dependencies between them, the utilization, the application binaries that are running on top of those guest operating systems, and anything that may not be entirely portable or able to be automated, could be a good first step. We'll talk about some workloads on the next slide that are typically quite easy to move. But being able to identify where the sources have strong or hard-coded dependencies on things that we cannot take with us is typically the thing that we'd like to do, and identify some quick wins. So step 2, I guess, is around being able to migrate the workload to Kubernetes. So being able to auto-containerize from VMs to containers in Kubernetes. Being able to automatically generate CI/CD artifacts for day 2 operations, and being able to transform those stateful workloads as they're automatically transformed to run as containers in, say, a Google Kubernetes Engine pod, is going to be that interim measure of extracting the application out once we've identified it. But then step 3 is really around how do we leverage the ecosystem of services that we have landed in this platform. Now, beyond containerized infrastructure and having a managed service mesh for security and setting service level objectives and being able to manage the traffic between each of your services, centralized logging, monitoring, application performance management, observability, declarative config, all of these things make it easier to go and run these applications in your target state. And I'm noticing that applications are also being extended beyond the move to be more API-centric. So then bridging to an API management solution that allows you to connect the infrastructure to your consumers, maybe with a developer dashboard, with API security baked in, and maybe even extending to some other services. I'm noticing that in many retail applications at the moment are bridging to data analytics and AI platforms. I'm noticing that organizations who are working with maps-based solutions are typically bridging those maps applications through APIs and are looking to scale them across different clouds across the globe, depending upon where their consumers are, for faster access and lower latency. So many different services, I guess, that we can consider along this journey. One of the easier wins to start with is typically around Java modernization. .NET modernization is probably another one. I'll talk about being able to transform some languages as we go through. But if we consider Java just as an example, it's probably one of the most prevalent programming languages in enterprise apps. Java and .NET combined around 85% of the application landscape that we see. If we onboard the Java app to containers and then automate it with a software pipeline, you'll probably see a 37% TCO saving in doing just that. But then with automation and software pipelines and refactoring, you can probably see an additional 78% TCO savings just by doing that refactor. So decomposing the monolithic Java applications to deliver services faster, they'll hopefully improve your productivity as we do that and as we automate some of those approaches that maybe you've had to do manually in the past. So the end-to-end journey, beyond the discovery and assessment, setting up that landing zone, maybe having that migration plan automated for you, created dynamically, as we go and extract the app out of the VM with a tool, and then integrating and optimizing the way that we take those applications to market through SRE practices of CI/CD and DevOps. So in terms of the report, what does that even look like? If we're thinking about an automated scanning tool. I got asked recently, why would we have a tool to go and discover what we've got? Well, I work with quite a few organizations that don't have CMDBs. They don't have a thorough view of the applications that they're running, the operating systems, maybe the utilization, whether they're over-provisioned, under-provisioned, or idle. They don't have a view on dependencies between them, the age of them. So there's a way that we can do this in an agentless and free way to go and collect details around the operating systems that we're running, before we choose to go and make that change. Now, one organization I was talking to in Thailand recently tried to move their key consumer web service from Thailand to Singapore. And they left many of their dependencies behind in Bangkok at the time. And they're wondering why the latency for the application actually accelerated after they moved to cloud, even though they were moving from quite an old platform. And it was those dependencies that really prevented the application from running well in its target state. So by mapping out those dependencies and application relationships, as you can see through this tool and this diagram, this is Stratazone, which Google acquired last year. I guess it gives us a really good view on all of the things that we need to consider as we do the transformation. And being able to dynamically map out the tiering of our application between web app and database tier, being able to understand if there are any other dependencies that maybe we haven't fully included in our view. And then having that timeline before we choose to migrate. We may choose to go and migrate the operating systems that are going end of life sooner, or the hardware that has the oldest age because they're going end of maintenance soon. Or maybe your cloud commit is coming up for extension soon and you're considering some options before you refresh that. So these are some things that might give us some good guidance around when and how to move, and automating the creation of some of those migration plans between tests all the way through to production servers. Now, the other thing I find is that executives and business stakeholders really want to understand what is the return that they're going to get from investing in this type of project. Is it just a technical driver that is largely not going to be seen as valuable to the business, to the CIO and the CEO and the consumers and the board? Or is it something that will largely help reduce that cost and reduce the risk of security breach and help them scale during periods of peak usage? So I would say that we can create a TCO chart that is either very simple like this or multi-page, up to 20 or 30 pages potentially, extracting out some of the details from the previous Stratazone tool that you saw and mapping it into a modern applications view. So we can layer in the effective improvements that you get from automating the refactoring that you might need to go through, and through automating the code conversion from a legacy language. And we can roll some of those benefits into a view that talks about what the impact is going to be to staff productivity and what the impact is going to be to business agility and how we're going to improve operational resilience as a result. Now, once we've done that, the business is solved. The business is keen on moving forward with this initiative. Identifying the first mover or the first workload to go and modernize is going to be key. The first monolith can be challenging to identify, but I guess if we can collect enough of the data and provide you with the views on what might have the highest business impact with the least risk and the lowest manual effort to go and modernize this workload, then that probably helps. I would say that choosing a very proprietary app to start with is probably not a good choice. I've worked with some organizations in the telco space and elsewhere, and one of the first applications they wanted to move was Siebel. Well, Siebel might be a bit of a challenging one to pick up and try and containerize, especially in an automated way. it's typically going to have a bit of manual effort there with some proprietary tooling to go and make any change. So do definitely consider the application that you're looking at and use data to make those decisions. Now, once you've done that, being able to map out migration waves, depending upon how high the business value is and the level of effort. Typically, we start with low levels of effort to go and move in wave 1, all the way through to those in the later waves that have low business value and maybe a higher effort to go and implement. So one way that we can identify this is through another tool set called the Windows and Linux Discovery Tool. So it will actually give you a score between 0 to 10 on how easy it is to go and containerize your application. Now that's not extracting microservices out from your monolith, but it's the first starting point. So these tools are freely available from our site, the Windows and Linux Discovery Tool, and they can be run completely in isolation, disconnected from the internet and cloud. And essentially, if you're at a 9 or a 10 in the scale as a result of running this tool, then you'll likely be able to modernize that workload and move it to Kubernetes with minimal manual work. So a lot of the migration will be done by the tool set itself. However, if you're between 0 and 4, then you've probably got high levels of manual effort required to go and start containerizing that app to start with. So there's a flowchart that we can go through, and we can have a look at the complexity of the application, prioritized by key decisions that you might want to make. So your platform type, or I guess whether it's strategic or not, or whether it maybe has a roadmap to be retired in the near future. These are some things that really help us to break out views before we get started. Now, building a migration factory is typically a good way to start, and this is recommended, I guess, in SRE cultures for modernization. We have repeatable ways of doing things. So I would say that the migration waves should be built into the migration factory, creating those automated migration flows, automating the test and validation of the workload once it's landed on its destination platform. We may choose to optimize certain things. We'll talk more about the optimization in the next few slides as well. And then we can improve the process before we go into wave 2. So by improving the process, we're basically adding agility and scale to the process. So we may start with a smaller batch or a smaller wave, and as we improve the process, that can grow as time goes on. So the view, I guess, is more going to be driven in this session towards what can we do to optimize moving into a change factory based off that migration sprint to refactor and transform those applications. So beyond the discovery, I guess some of the key questions that really we should ask is, where is this monolith? Is it running on-prem? Is it virtualized? Is it running on bare metal? Is it on a mainframe? Is it hybrid in architecture? Does it scale web services in the cloud but other services on-prem? Or is it fully in the cloud? Now, which path are we choosing to take? Are we taking a services-based modernization approach or a slice-based approach? It'd be good to look at some design patterns, and we'll talk about some patterns in the next slide, as to what it may look like to get some quick and easy wins. And then a point of view on sequencing and phasing, which we'll talk about through this stepped approach next, and then some sample architectures by service. So these are some of the things that we're going through in the next slides. So in terms of the monolith, typically it's leveraging many vendor-provided tools to make any content and code change. It may be outsourced or might be managed by a solutions or services integrator for you. It may be of the type of IBM WebSphere, Oracle, SAP, maybe Salesforce Demandware, or any type of very proprietary software that you've started with, or maybe has been around for quite some time. It may also have been custom built with likely very little change these days. So all requests are typically going to be handled by a single application code-based platform, and all data is going to be held by a single common database. And it may look like this. So you've got your database tier, with your common primary database and maybe your secondary common database. You will likely have your application tier, where you've got your core e-commerce, if you're using, say, an FSI or an e-commerce app, in a single application package that includes content and checkout and orders and session carts and inventory and front-end UI. It may have a load-balanced application server on the front end. There may be a search implementation there with an index feeding through to the database. And then the web tier will likely be load-balanced via the perimeter firewall. And typically all of these, in many organizations I've worked with, are running on-prem in a data center. Sometimes they're virtualized, sometimes they're not. Now, we've talked about some of the challenges, but I guess a more extensive list. And the reason why we're making this change is basically to avoid lock-in with licensing and allow us to more dynamically change the app as our business needs to change. As we've noticed over the last year and a half almost with COVID, I feel like most organizations are being pushed to build features more dynamically and offer services through apps rather than face-to-face these days. So moving away from monolithic architectures that have a very long lead time for change is typically going to help businesses scale. So one of the other obstacles, I guess, is that often there is very little innovation with these traditional monolithic platforms. So because they are packaged, we're basically waiting on our software vendor to release a new version before we can go and implement any improvement. And in many cases, even after the software vendor releases an update, organizations I've spoken to haven't been able to upgrade or update their software because maybe they follow an N-1 or an N-2, or even seen an N-3 update cycle, where you need to wait for 1, 2, or 3 iterations of an update to be delivered before you can then go and update the estate in your own organization. So this is not very dynamic at all. But many organizations still have these. Now, in terms of the goals, being able to identify the platform is probably the first starting point. So being able to map out the key design considerations and patterns are going to help us make the right choices as we follow this phased approach. So choosing a platform based on our availability requirement, performance requirements, security requirement, manageability, cost requirements, all of these things are going to help us choose where we land in our target state. So in many cases, choosing multi-region may give us access to new markets, maybe improved response times for consumers that might be sitting further away from where our current data center is. I would say that re-architecting to a custom microservice offering will allow us to improve agility and improve the time to market for new feature development, break free from those vendor models, provide more advanced features and personalized experiences. And I've seen this typically in the e-commerce sense, maybe leveraging ads through API-driven approaches to your application to provide more dynamic and updated ads for your consumers within your site, or AI-driven analytics that might provide us with more dynamic changes to the application and scale based on where we sit, or even the manufacturing cycle. So based on the consumer demand, we can maybe optimize what we manufacture and where we manufacture it, so we can deliver faster to our consumers. So the quick win, the first thing that we often start with, I guess, is anything that's largely static, a static asset, we call it. I guess this might be an image, CSS, fonts, thinking about maybe moving these typically because there might be an improvement in cost. We can optimize cost by maybe centralizing these static assets on cheaper storage, more dynamically scalable storage, and maybe not being held to the life cycle of our storage area network that sits on-prem. So a cloud CDN would reduce the response time to go and deliver the image to your consumer. So there's also ease of management. It's pretty much a hands-off approach. You no longer need backup, so you're typically saving on backup restore effort for your team. You'll accelerate the serving of your static content, and you'll build experience and confidence in running that production service on the cloud if you start with development first. So what does that look like? I guess architecturally at a very conceptual level, we've got our cloud CDN here sitting on GCP. It's got cloud load balancing in between your CDN and your cloud storage. But then you've still got your on-prem data center with your perimeter firewall at the outset, serving the largest portion of your monolithic app as it is today, the app that we spoke about previously. So what does phase 3 look like? I mentioned APIs before, but basically if we have an API management services layer inserted between the monolith and our client consumers, we could build a web-based UI presentation layer. Our mobile apps will be more natively driven towards consumer-centric devices, IoT, maybe smart devices, and I guess may help us to future-proof the app going forward. I guess the API must give us a decoupling from the monolith's data and the services that we deploy as well. Now, in terms of the business benefits, we're essentially hiding some of that complexity. So APIs will give us that standardized and consistent access to these resources. It'll give us a more true omni-channel experience as consumers are typically consuming our core e-commerce functionality via a single API now. So what does that look like? If we extend this architectural view a little bit more, we've now introduced our API gateway, giving API definitions and contracts, including, I guess, checkout and orders and a session cart and maybe inventory, SKU price, store front UI. And then we're bridging to that cloud load balancer through our gateway, once again to our core e-commerce services, which are sitting on-prem in our data center, bridged through our CDN, which we spoke about previously, to our web servers and application servers. So if you think about this API gateway, at Google, we find that our customers are often deploying Apache for this purpose, being able to bridge from the consumer to the hybrid infrastructure, or the infrastructure as it sits on-prem via an API management solution or API gateway is a good phase 3 approach. Now, if you think about phase 4, and this is a little bit text heavy, but you'll see the visual in the next slide as well. This is typically where we're extracting the presentation layer out to be a little bit more flexible to change. So we can basically optimize the layer that our end consumer browsers consume. The improvements in response times within the browser, being able to provide a responsive single page application is critical to ensuring that consumer services are improved. Now, content management system, will assemble that front-end application or components deployed to a cloud so that it can scale as we need it. Now, why would we do this? I guess speed to market of new features in the presentation layer is instantly recognized by our consumers. And I guess I see this regularly, even with Gmail. I did not have to go and update anything on my side in order to receive the new features for mail, but they appear there. So in a similar sense, I guess if we're looking at an e-commerce application, I'm using my banking application, those services appear much more dynamically when we optimize this presentation layer. So the business is no longer constrained by the rules of the monolith for improving application functionality, and maybe improving those process overheads, and technology limitations are not really a constraint for feature design. And this is probably one of the most consumer-facing parts of the transformation. So what does this look like? As we spoke about, we've got our CDN and our API gateway in smaller boxes now as we zoom out to our presentation layer. So we can see in the middle Google Cloud Platform box there, our presentation layer has been broken out in blue, where we've got our single page application on our SPA assembler, running on a compute engine, and our content management system running on our compute engine as well. And both of those are being brokered through by cloud load balancing before, I guess, they connect via the gateway through the perimeter firewall to the rest of the monolith on-prem. So quite a dynamic area to go and optimize, and we've got some recommendations on ways that we can do that as well. So phase 5 is around improving browse and search. So if we think about the search engine response to build the PLP, which is the product lister page, this is often a JSON or an XML, which the browser would use to render those products. So we often find that if consumers are using a free text search for navigation within the single page application navigation tree, they're going to be constrained if we don't go and optimize that browse and search experience. They're not going to find what they're after as dynamically as maybe what we would like them to. So the business benefit here is to go and customize that product lister page so that we can provide better search result accuracy, which will give us a higher conversion rate. It'll give a more customizable browse experience, and it'll move the data closer to the end consumer, which lowers the response time. So what does that look like? Now, if we break out in our GCP box here once again, we've got our Cloud Armor and our Cloud DNS partnered with our Cloud CDN at the start, talking through our cloud load balancing, through to our presentation layer with our content on compute engine, and then our Cloud VPN and our dedicated interconnect talking back to the rest of our monolith on-prem. So slowly we're getting to a stage where there's very little left of that monolith sitting on premises. But let's have a think about what else we can do here. So personalization is probably one of the things that has been more difficult to do in monolithic applications. And we're typically very reliant on the software vendor if we're going to go and offer any improvements to personalization. So consumers often would like to create their session when they go and start a journey and browse the site. In this example, an e-commerce site. Traditionally, having compute and database overhead for the session, it's not often dynamic in the monolithic architectures to what we may compare, once we've extracted into microservices. So when we host, all of these browse requests based in the cloud can be recorded in a single session state. We're not connecting between cloud and on-prem anymore, and we're often lowering the performance impact on that monolith. So we're freeing up capacity that we may need, and we're providing many of these options in the cloud, which gives us scale as we need it. So for the consumer, faster browsing times, better user experience, key details relating to their session, which will give them that one-to-one mapping between their session and, I guess, their experience. Now, what does that look like? We're getting a little bit more complex here, breaking up all of these different components, but we can see our presentation layer, which we spoke about previously, and our load balancer with our CDN and our API gateway. We can see our search service down the bottom of that middle gray box now too. Now our search service may run on compute engine via our load balancer, talking to search on maybe a cloud data store. And our session service running on compute engine might be talking to our session store, also on cloud data store. And then we've got our extract server, which will go and lastly communicate with our core e-commerce services. So we don't have as much of a reliance per se on on-prem anymore. It's more for some of these core services that we are largely dependent now. So last phase, decommissioning the monolith. And then we'll talk about some options around how we can maybe help with doing some of these things in an automated way. So decommissioning monolith really helps us to optimize and deliver what we've done through the last 6 phases. It typically means that we can extract ourselves completely out of the on-prem deployment, the data center, or our colo, and we can essentially what they call strangle the monolith, which is based on the strangler fig, which if you've ever seen those, typically eventually strangle the tree that they go around as they grow. Now, I guess to put a positive spin on it, I would much rather say that we are able to optimize and deliver and retire the monolith because we no longer need it. So putting it out to greener pastures. Now, if we think about the business benefits of doing this, we have a completely flexible and unconstrained environment now. It's easier to deploy service changes without impacting the overall platform. We can go and make updates to any of those services, those microservices, without having to have a change for the entire platform. And we can roll back much more dynamically, and we can even scale out portions of these updates if we use a service mesh, an API gateway, and CI/CD to offer canary clusters for maybe 5% of the traffic goes to the newly upgraded service, and we slowly roll that out to 10%, 15%, 50% before we eventually direct all traffic to that newly upgraded service. So by doing this, a lower TCO, there are no repeating large multi-year license fees. The platform is optimized and right-sized depending upon usage all year round. Now, I would say even beyond that, the main thing that I'm noticing with organizations these days is modernizing to serverless allows you to scale down in some cases to 0. So if you have your application running in a container file with the language of your choice, you could choose to go and scale it down completely if there is no consumption of your application, and then scale it up to the capacity of the cloud as you have some of those peak periods, which means that you're not having to manage scale of your Kubernetes environment, your pods and your clusters as much as what you might need to. Extending to serverless gives you more of that TCO benefit. But still, I guess managing Kubernetes with a level of automation will give you better customization. It will allow you to manage it in the way that you would like to manage it. Maybe offer different changes on security and compliance depending upon what your business needs. So the operational overhead compared to what we would typically have to do with a monolithic application is much less now that we have moved to this architecture. where we can see many of the components here, all the way from our API gateway to Cloud DNS, Cloud Armor for security, our CDN, talking through our load balancer to our presentation layer, our cache layer, maybe running on Cloud Memory Store, our services layer, including search, SKU, account services, orders engines, inventory, and then to our storage layer, which would include our search, products, accounts, sessions, inventory, and orders. So a couple of best practices here. If we think about key things that we would like to consider when doing this, typically every service that we modernize or deploy should have its own database schema. That's regardless of whether you're using a relational database or a NoSQL solution. Services should only communicate through their public APIs over the network. So all services should expose their behavior through public APIs, and we should have well-documented and supported APIs as part of that process. Now, services should be responsible for backwards compatibility for their clients. So the team building and operating the service will be responsible for making sure updates to the service don't break its consumers. Now, we can also see that we don't want to introduce any downtime by using techniques like blue-green or canary deployments, as I mentioned before. We can go and scale our new updates incrementally to very small volumes of our consumers, reduce the impact if there's something wrong. Now, if we think about creating a standardized approach to running these services on deployment workstations, the developers often will need to stand up any subset of production services and development on either development workstations, development clouds, edge development instances I'm seeing as well, and it should be portable. And it should be possible to run these stub versions of services on demand. So portability of packaging and dynamic scale and management of these apps is key. And then one of the last ones here, investing in production monitoring and observability. So we can cover off a whole session just on observability and the metrics that you might want to consider monitoring, but it's typically one of the more important topics when you're thinking about achieving business service level agreements or SLAs. So if you have any issues, performance problems, uptime issues, interactions between consumers or dependent services, having that observability in place for the metrics that help us understand how to serve your application well is going to be key. So in terms of the roles, and then we'll talk about some of the tools beyond the text. If you're in platform engineering, you're often trying to automate and reduce the manual effort in the frequent upgrades that you do. Having managed services, having migration tools is going to be quite valuable. For developers, maybe IDE and CI integrations, building pipelines that give you full CI and CD, leveraging serverless, as I spoke of, to reduce the administrative overhead and obstacles, and maybe gaining infrastructure from the infrastructure team, and having an API-first approach is probably going to help you get started on this journey. For service operators, you're likely going to want to leverage the simple deployment and rollback and canary clusters, blue-green deployments that we spoke of. You're probably going to weigh in quite heavily on visibility and observability with logging, monitoring, and performance management. You're going to likely be interested in a managed service mesh that will allow you to encrypt traffic with MPLS between each of your microservices that you have deployed in that final architecture we spoke of. And maybe you might be interested in being able to have declarative configuration management, where you can deploy all of your policy in one manifest, pull it down from Git as a single source of truth, and scale to all your clusters. Now, from a security aspect, that's probably also another consideration, where GitOps style approach to security or DevSecOps might be one of the more topical things for you to look at. And we've got some great best practices we can talk about in that space, and shifting left on security in your pipeline. And then having full software supply chain integrated with identity policy and attestation are probably some things that you'll be interested here too. So this isn't an extensive view, it's I guess a view of the journey. There are many things that contribute to this modernization path. I would say that analyzing the estate, as we spoke about early on, is really going to help. Whether you're migrating, leveraging the tools like Migrate for Anthos or G4 will help you migrate either workload or code with G4. If you're building new, having repeatable code libraries with Cloud Code is going to save you some time. Automating the build process with Cloud Build and some other tools that we'll have come throughout the year. In addition to low-code and no-code options like Firebase for mobile apps and AppSheet for no-code app development. Centralizing through an artifact registry, replacing proprietary with open source via the marketplace with centralized billing, and then running on your chosen platform, whether it's serverless with Cloud Run built on Knative, GKE built on open source Kubernetes, or functions and App Engine in our serverless portfolio give you a bit of choice. And then the extensive observability aspect there too. Now, we've been doing this for many years at Google. We schedule several billion containers per week. Well, that was, I guess, last year. We've exceeded that number now. But we've been doing this since 2003 with the birth of Borg, all the way through to releasing Kubernetes to market in 2015, and Istio in 2018, Knative for serverless around that time too, and then with Anthos in 2019. So Anthos, I guess, is the technology aspect to this. We've talked about the process. We've talked about some of the operational views that you might need to consider. Now, I guess the view should be inclusive, and portability and flexibility was part of the message. So if you've got that declarative policy management with Anthos config management, if you've got centralized and consistent container management, if you've got a managed service mesh that gives you production support, where you can encrypt traffic between your microservices, and if you've got that centralized logging, monitoring, application performance management, build, deployment tools, CI/CD pipelines, serverless, and migration tools, that will likely save you if it's the same, regardless of whether you're running on Google Cloud or Amazon or Azure or vSphere, bare metal. It could be Ubuntu, CentOS, Red Hat, OpenStack, or even if you'd like to go and manage someone else's Kubernetes. Maybe you're not wanting to use GKE because you've already invested in one other platform. It may be EKS, AKS, OpenShift, maybe Rancher. I guess being able to still have the management capabilities on top of those attached Kubernetes clusters can add some of that value around reducing maintenance. And then connecting all of that infrastructure to consumers through your API management solution with API analytics is what it looks like. Now, I spoke about code conversion, and here's one example. I'm mindful I've got about a minute left. But speaking with organizations running legacy languages like COBOL or Assembler or RPG, being able to automatically analyze that code and convert it with a tool through to a modern language like Java is something that will likely save you as developers a lot of time. I was speaking to a developer who had to port a financial application from COBOL through to Java on Kubernetes for a large financial institution. It was probably about 2 years ago now. It took him and his team over 12 months to go and do that for the application. So I guess we're offering to automate a lot of that where possible through software. Save the effort, reduce the overhead, and only change what you need to with the manual intervention that needs to be done. Now, portability to containers is typically done with Migrate for Anthos. It'll extract that application out that you've analyzed and viewed in your estate and move it to a container file with the YAML manifest, which you can run on top of GKE and Anthos and Kubernetes. The approach typically looks like this, where you go and set up your cluster, configure your sources, regardless of where they may be, and then choose your migration, your source. You go and generate those artifacts, you go and test, and then deploy and integrate within your CI/CD pipeline. So there is a demo that we can show you maybe at a later state, given we're probably out of time now, but it looks a little bit like this. So you can go in and have a look within your GCP console, go to Anthos, choose migrate to containers, and you can go and see how to generate those artifacts automatically. Now, the demo just goes through the step-by-step of choosing the workload from the source and showing what those artifacts look like. I guess in terms of getting started, do reach out. I would love to hear from any of you if you'd like to get started with this journey, or just share your experience in terms of something that you may have done in a similar context. But let's assess your applications, let's build the business case for your executives. And if you'd like a little bit more reading, there are some other great ebooks out there. There are some by O'Reilly, the SRE workbook, Site Reliability Engineering. There's also one on Monoliths Microservices by O'Reilly too, which you could read. So I'll pause there, given we're at time, and just see if there were any questions or anything that I can help with.
Thank you, Andrew. We do not have any unanswered questions. So there were 2 questions, but then someone from chat has already answered that. Do you have anything else to share? Maybe you can share your social media handles. That would be
yeah, sure, absolutely. So if you'd like to get in touch, you can also ping me on Twitter. You can see my last name there is Hashka. If you'd like to email me, it's just hashka@google.com. Very happy to hear from you. If you've got any questions and you don't want to ask in the community, feel free to reach out with those questions separately, and we can talk about them. But beyond, I guess, that, there are a whole bunch of things that we can help evaluate culturally within your organization too. So evaluating your maturity and readiness for having delivered version control or trunk-based development, leveraging CI/CD, maybe doing test automation, having loosely coupled architecture and 12-factor apps, having event-driven architectures, leveraging maybe team experimentation. All of these are topics that maybe we can talk about if we have some more time as well. So if you're interested in any of those things, please do let me know. Really keen to hear from you and see what we can maybe do over the year.
Yeah. So this was really nice, Andrew. We'll definitely get in touch with you, and we'll try to have one more session, or maybe a couple of more sessions. Thanks a lot. Thanks for being here. I'm sure this video will be helpful for a lot of others, and in fact, I'm going to watch it more so that I understand more. So thank you for being here.
No problems. Hopefully sometime in the future we can have a physical event and all get together to chat afterwards. But thanks for running this. Really appreciate it. And we'll chat to you on the next one.
Sure. Thank you. Bye.
Thank you.